Hello everyone. I know it's been too late to upload this new video again because since last time we hit 20 likes and now it's been like a few months already. So today we're gonna take a look at the paper 2 in time zone 1 of the 2024 May AAHL paper. Okay, so let's go. Okay, number one. Number one, this is a pretty easy and straightforward question. Let's read it together. So Darren's buy the car for 35,000. The car decreased by 15% in the first year. Calculate the car value of the first year. So we can then calculate quickly, which is like 35,000 times 1 minus the 15%, right? So you use your calculator, 35000 times actually 0.85 because that's 85%, right? So you're gonna have 29750. Okay, so that one is a pretty correct answer. So next, part B. After the first year, the value of the car decreased by 11 in the subsequent year. So find the value of Darren's car in 10 years, give it to the nearest dollar. So for 10 years, how does that exactly go? So we have to draw a little bit of the timeline first. Right, that's year zero, and that's year one, and then year two, and then year three, all the way up to year 10, right? So after the first year, actually, it's going to be 1 minus the 15%, right? But then for the year after the first one, like each of those years are actually 1 minus 11% because they decrease by 11% each year, right? So now my question is, how many times does that go through the minus 11%? Except for the first year. Now, out of the 10 years, only the first year is actually experienced a 15% decrease. But then the rest of the 9 years are actually decreased by 11%. So if you want to recognize that this one is actually got 1 year, but then the 1 minus 11%, it experienced for 9 years. So the things that you can do is you can copy your answer from part A, or you can just still write the original 35000 times 1 minus the 15%, that's the first year, okay? And then times 1 minus the 11% for 9 times. Be careful for this 9. Instead of the 10, you should put a 9 there, okay? So directly, you can use your calculator, directly press multiply because that will show you the answer. Answer times bracket 1 minus 0.11 close bracket to the power of 9, press enter, and then your answer should be 10423. Okay, that's it, because you're going to be correct to the nearest dollar. Okay, so then the next one is part C. When Darren's want to own car for n complete years, the value of the car is less than 10% of its original value. So now the thing is, again, out of the n years, like out of the n years, you think a little bit, only the first year is actually decreased by 15%, right? For the rest of the years, that means you're going to have n minus 1 years. That's going to be experiencing minus 11%, okay? So bear this in mind. So instead of we use n minus 1 as the power, okay? So then what you can do right now, part C, you're going to set it up first. So you're going to set up the now, actually, in this case, you do not have to, uh, or you can just find it out first. Okay, so 10% of the value, which is like 10%, 10% times 35000 is equals to 3,500, right? So that means 3,500 times the 1 minus the 15%, and then times the 1 minus the 11% to the power of n minus 1, right? It has to be less than 3,500, okay? So quickly, actually, you can do both. You can do both sides divide by 35000, divide by 35000. And then, of course, we simplify, and then we're going to have what? 0.85 times 0.89 to the power of n minus 1 has to be less than 0.1, right? So, and then we'll move things over, right? So divide both sides by 0.85, you're going to have 0.89 n minus 1 less than 0.1 divided by 0.85. Now, in this case, you can actually input in your calculator, but if you don't have the calculator, if you do still want to see how the things go, you can take the log. So we're gonna have what? We're gonna have n minus 1. Remember, bracket it whenever you take the log, 0.89. And less than what? Let's just log of 0.1 over 0.85. Now, our n minus 1 has to be less than. Okay, now first of all, we're going to check what is a log of 0.89 first, because if it's negative, we're going to change the sign. Oh, yes, it is a negative, right? If it's a negative, then we got to do something, which is we have to change the sign. That means we have to change the sign like this, and then we write it as log of 0.1 over 0.85 divided by log 0.89, okay? So then now, let's press our calculator of log bracket 0.1 divided by 0.85, and then enter. You see actually that this one is a 0.92 something. This is 0.05. So then now we can directly press divided by this answer. So you're gonna have n minus 1 bigger than 18.364. So let's continue. Both sides add 1, n is bigger than 19 point. Sorry. Oh, yes. N is bigger than 19.36. So since the n has to be an n complete years, if it is right at 19 years, it's not yet the 10% because it's 19.3 something to become an complete less than 10%, right? So that means therefore n it's equals to 20. Okay, that's what you have to write. Okay, question two. Question two. Now, usually when we do AAHL papers, we don't usually read this one first. We read the diagram and we read what is going on here first, okay? So let's read it together, see what we can actually find, okay? So now we see there's a person 1.8 meters high, and then that's included in this 20 meters, right? So that means you be able to subtract the height, and then the person, it's away from the base of the cone corner by 5 meters. Now notice when we're trying to actually minus it, we have to bear this in mind. This part is actually a 5. Okay, this part is actually a 5. Okay, sometimes you think that, oh, even this part is also the 5. That's not the case. Okay, so then now what we have to do is we have to find the radius of the base of that. Okay, so here comes the big problem. It's we do not the the dimensions, right? So the things that we can do right now, it's we can we can read this one a little bit. Okay, so that one is the radius, right? So that means the whole thing. Now, if I highlight the whole thing, this whole thing, which is what? This whole thing is called r plus 5, right? We shift this r plus 5 or shift it up like this. So this line is still r plus 5, right? This line is still called the r plus 5, okay? And then that fits into this right angle triangle. So if we roughly sketch it out, you're gonna have something like this. Okay, so that's gonna be 58, right? The height, now be careful because we're gonna shift it up by 1.8 meters to adjust with the person's height, right? So that's gonna be 20 minus 1.8, okay? Whereas the bottom, this one, that's actually the r plus 5, right? So now one equation, want to know, we can use tangent to solve for it, okay? So then now let's write the part A first, okay? So then we can write down tangent 58 degrees equals to what? Equals to, now we write every single step, so that's 20 minus 1.8. Sorry. And divide by r plus 5. So now Like, be careful when you're trying to use your calculator. The thing is, when you use your calculator, um, this is in degree mode. So make sure you have to switch off to the degree mode first. Okay? So then, why can't I quit it? Okay, yes. So then now we press tangent 58 degrees. That's going to give us a pretty nice number there. Okay, because we're in the degree mode. Okay, as you can see. So now we still write it, okay, which is tangent 58, that's equals to 20 minus that, which is 18.2 over r plus 5. So that means our r plus 5, we do a little bit of the change of subject. It's 18.2 times the tangent of 58. So now you can directly use your calculator since we just calculate what tangent 58 is, right? Times 18.2. So r plus 5 is equals to 29.126, right? So then we have to minus the 5. Hey, did I calculating anything wrong? Tangent 58, there are changes to degree mode? Yes, I am. Tangent 50, is that 58 degrees? Yes. Tangent 50. Okay. And then we're gonna times the 18 point, oh no, times 18.2, gee. So after we write down the tangent 58 equals to that, we're going to do a little bit of change of subject, which is r plus 5 equals to 18.2, and then divided by tangent 58 degrees. So that means we have to key in, okay, 18.2 divided by our answer here. So that's going to be, so r equals to 11.3726 minus the 5. So R equals to 6.3726 dot, 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 dot. Okay. So since we have to give our answer into three significant figures, so we can then write it as R is equals to 6.37. Okay. So now part B. Find the volume of the whole thing. So that one's pretty straightforward because we have the formula, right? The volume formula is what? It's 1/3 times the pi r square height, right? So which is 1/3 pi times the r, which is 6.37. Okay, we write it from our answer, but then we calculate it, use our calculator value. Okay, so minus 5 first. So then now we key in everything that we have here to calculate that. So which is like uh the answer we have to squared it, and then times the 20, and then divided by 3 at the end. Of course, sorry, we forget to multiply the pi. Where's here? Okay, yeah. So then our answer should be 850.540 dot, 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 which is equals to 851. Okay. And did it get the unit? Yes, we have to give it meter cube. Okay. And then again, it's to the three significant figure. Okay. So that's question 2. Move on. Question 3. Question 3. Okay. A random variable x, okay, it's normally distributed with the standard deviation. Okay. And then with a mean of 10 and a standard deviation of 2. Find the probability of x is 1.5 more than above the mean. So roughly sketch it out. This is a 10. Standard deviation is 2, right? So it's 1.5 standard deviation above the mean. It means roughly about here, right? And that's going to be, what's the point? That's the point. 1.5 standard deviation, which is like plus 3, right? This gap is a 3 because 1.5 times 2, that's a 3. And then, so that's 13. And then they are looking for the area that's more, that means above the mean, right? Okay. So then now, what is the first thing we can do? We can use the variance, right? Sorry. We use the distribution, and then we have the normal CDF instead of PDF, because CDF means cumulative, right? Accumulation. Okay. So let's just press enter. Normal CDF, we have to press the 13, okay, and then comma. And our upper limit is you can just put it as a big number as possible, and then comma. And then what it's the mean, that's a 10. And then the standard deviation, comma. What's the standard deviation? Standard deviation, it's a 2. So we press enter. We're gonna have what? We're gonna have, like, we write out first the P of x is bigger than 13, and which is equals to normal CDF, okay? CDF of 13, infinity, 10, and then 2. That's equal to 0.0668, okay? Again, 3 significant figure, okay? So part B, probability of x is bigger than k standard deviation above the mean of is a 0.1. So we're gonna use the inverse norm, okay? So we're gonna use the inverse norm because now if we sketch the diagram, that should be look like this. Again, this is a 10, that's a 2, right? So when it's asking for the k standard deviation above the mean is 0.1, that means now they give you that, okay, this part is actually 0.1 already. Then you're going to deduce about what is this number, okay? And then this number has to further divided by 2 to know it's how many standard deviations, okay? So the things that we have to do is we use the inverse norm. Inverse norm, okay? So again, we kick in second and then var's, that means the distribution, put in number 3 inverse norm. The norm, now, you have to be very, very careful because sometimes your calculator, it directly asks you to input the area. And some older calculator, you still have to input the area from the left-hand side all the way to the right-hand side, okay? Because above that particular point by 0.1 as the area, it's equivalent to less than that point by 0.9, right? Because it's to the right and to the left concept, okay? So that means that if you have the left tail or right tail, that kind of calculator, you can directly choose 0.1 and then choose the right tail, okay? But in this case, our calculator is just like a free version, so yeah. In this case, we have to input our area as a 0.9 because you can see the distribution. The whole thing is actually 100%, right? So that means the left-hand side here is actually 90%, whereas the right-hand side is only for 0.1, which is like 1%. Okay. So then now we input, okay, we put in 0.9, okay. The mean is actually the 10, and then the standard deviation is a 2. So 0.9 calculator, comma, 10, comma, 2, enter. We have that one as a what? As 12.563 dot 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 dot. That means this particular point right now is called 12.563 dot 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 dot. Okay? So now we have to subtract it first, okay? We have to subtract by 10 and then divide by 2 so that we know what is exactly the number of standard deviations, okay? So then therefore, k is equals to 12.563 minus the 10. We have to subtract the distance from the mean first, okay? Then we have to divide it by the standard deviation 2, okay? So we minus 10, enter, divided by 2. So our k is equals to 1.28, okay? So that's the free significant figure answer. All right, move on. Question 4. Now, question 4, this one, I think this paper looks like look alike the AASL paper in the same year. Okay, so if you haven't checked it out, you can just check it out first. Okay. Yeah, and basically you can see a lot of question it repeats. Okay. So question four, what do we see here? Now we have to find this is basically, there's a VT graph there. Okay. And then we have to find the smallest value of t where the particle changes direction. Now, this is a VT graph, and they ask you when did the particle change the direction. What does it mean by change direction? That means from going forward, and then you change it to, going backward, right? Okay, that's the first case. Or originally that guy goes to the back first, and then suddenly it stopped and go to the front. Okay, so that means this guy go to the front first, stop, and then going back. That's one case. Or the original guy is going to the back first, stop, and then start to going forward. Okay, this is called change the direction. But in the VT graph, what does that mean? That means it changes from the negative area start to be the positive area. What does it mean? Because we know that the area occupied under the VT graph stands for the locations, or stands for the direction it is moving. So that means from at this part, it's actually moving backward, right? Okay, because the VT graph is a negative. You're going a negative velocity, that means you're going backward, right? Since we have a direct number, right? And so as this part, right? This part is actually going backward. Okay. When is it going forward? That's when the VT graph is above the x-axis. That means it is like going half a forward. This is a positive version, which is like it going forward. Okay. So why does the question have to emphasize when the smallest value of t when it changes the direction? Because you take a look at two places. When does it start to change direction? Either from this part, right? From negative to the positive. Okay. Or from the positive part changes to the negative part. So essentially, you will have two t's that it changes direction. This is the first t, right? And that's just another t that it changes direction. So by comparing the left and right, this is a smaller one. So we're going to check this one first. Okay. So I think this one we can just directly use a calculator because it's just like a 2-point question. So, but then we don't know which zero we are solving for. So then we can but first, we still need to write it out first. The smallest value of t is when the equation is equal to 0, which is when the v equals to 0, okay? So we have, which is like 2 sine of what? 0.5 t. Now, notice this one is a 0.5. When it comes to a small value, you have to make sure you change it back to your radian mode, because usually, if you forget to change it, then the whole value is going to be so wrong, okay? And then plus 0.3 t, and then minus 2. So in this case, what can we do? We can then input our equation, which is like 2 times the sine of 0.5. We don't use t, we use x. I just delete it, yes. 0.5 and then x. Okay, and then shift to the right, and then plus 0.3 and then x, and then minus 2. Okay, and then graph. Okay, so now you can actually see the graph that's being shown there. Okay, so let's say we zoom in a little bit, and then we zoom in a little bit again. Okay, so now actually this one matches with the graph that we're looking for. So you see the 5 is roughly at this place, right? And then 5 is roughly at this place, right? Then we can do a little bit of trace. We can't trace it, but let's use some analysis thingy. So which is actually it tells you what the zero is. Okay, so from your calculator you can directly see, okay, this is 1.68695. Okay, so that means your t your t first hits the zero at 1.68695. Da, 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 da. That means t is equal to 1.69. Again, to correct to the nearest, sorry, correct to 3 significant figure. Okay, so part B. Find the displacement. Find the range of values of t where the displacement of the particle is increasing. Now, just now we talked about if it is going under the x-axis, it is going backward, right? Which is it is actually decreasing from the uh, displacement perspective. So now we have to going forward. Forward, what does it mean? That means we only take a look at the green value there. So now we plot out the first point, which is like 1.68 68695, right? We have to find the second one, and then we have to find the area that's between these 2 points. All right. So then now let's move on and then trying to trace what's the next point. Right, now they give you the second point. Again, on the graph, you can see that actually the zero is actually 6.11857. So now from the calculator, we mark it down for 6.11857. All right. So then now the things, basically uh, we just have to find the range of t, right? So that means, therefore, for the v has to be above the zero, and then the t is actually 1.68695 less than t less than 6.11857. So which is 1.69 less than t less than 6.12. Okay, again, to the three significant figure. Okay, so that's pretty straightforward. Nothing else against the 2 point. Find the displacement of the particle relative O when the t is equal to 10. Okay, so again, we can go back to the calculator mode, and then the particle, which is like a integration. Now, regardless of going forward or backward, they just want to find a net. That means you're going backward, going forward, this guy going backward, going forward, and then at the end, how far is it from the relative position? Okay, so the things that we can do is recognizing this is a integration, and then starting from relative to O, right? That means the starting position, which is when time equals to zero. So we have to integrate from 0 to 10, and then of this whole equation, which is you just copy down the whole thing, lah. Okay, which is 2 times sine of 0.5 t plus 0.3 t minus 2. Don't forget to put the dt because you're integrating with respect to the dt, okay? The time, okay? And then now what you can do, it's you can then integrate. So see what we can do to integrate that. So we can use math. Okay, and then let's go to the bottom a little bit. Eh, Integration. Okay, so then I have a 0 on the top. We have 10, and then now you can see that it default to be dx, right? So that means we have to change our t's into x when we are inputting, and make sure you're in the radian mode. Okay, that's why we change it back and forth. Otherwise, if you use degree mode, you're gonna be so messed it up. Okay. So you use 2 sine and then bracket, that's going to be the bracket for you, 0.5, and then alpha storage, which is the x, close bracketed, and then plus the 0.3, and then again alpha storage, which is the x, and then minus 2. And then check your thing, does it look right? And then you press enter. You just by calculator, that's why you can have negative 2.13 46 dot, 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 which is equals to negative 2.13. Okay, that's it. Okay, if you want to write it out, does it say any unit? Yes, it says meters. You see here, it says meters. So if you want, you can just give the meters as well, okay, as a unit. All right, so moving on. Now this one is a two, what is that called? A linear regression. Okay, I think, yeah, this is exactly the same paper as the AASL paper, so which is pretty much the same thing. Okay, but then you can actually see here, you have two sets of sort of like data. Then you need to write it down. What is exactly the slope? Okay, so before doing that, we're gonna go to the statistic mode, and then we have to edit it. So by the time being, I just input every number that we have there, okay? So this is pretty straightforward. Now, after we input it, we don't have to do anything. So we have to find the correlation coefficient, right? So we keep on pressing the statistics and then move it to the right-hand side, calculate, going down to for lean reg, which is linear regression. And not just they're gonna give you the slope and then the y-intercept, they will also give you how well do they fit to each other. So you press enter, and then you press also another enter. Okay, frequency list and storage, reg EQ, you don't have to input anything. You see the R there, it's 0.901, and that's your answer. All right. So part A, you're gonna write it out first. Your R is equal to 0.901. Again, you can say it from your calculator. Okay, but that's just a yeah, there's nothing else you can write because every step is in the calculator. So, or you can, if you want to just take it from GDC or from GDC, yeah, if that counts as a step though. But it doesn't really matter for AAHL paper. Okay. So part B, give a reason why this method is not appropriate for Paulo. So let's just read this one first. This person was absent for test A. This person was absent for test B. Teacher used a regression line of the y on the x. Okay, it makes sense, right? So Paulo scored 10 points on test A. Teacher used examine his score on test B to be 27 nearest integer using this following calculation. That means you substitute it in, right? So give the why this method is not appropriate. Okay, so let's take a look at here. What is the y on the x? Y on the x means you use the part A result. Okay, you use the test A result to figure out to try to guess what the B result is. Okay, so let's see what the A result look like because it said okay, it sounds makes sense, right? If you input a 10 point there, but since this test is actually out of 100 points, so then we get to see it's test A containing a result that is as worse as this guy called 10 points. Okay, so you see there's nothing. You see the ranging is actually 50 something, 70 something, 100 points. It's none of them is actually below uh 10 points. So that means if you have to roughly talk about the graph, since you can see the slope here, it's like 0 point something, and the regression is 18 point something. So if you can imagine the line looks like this, okay? And then the points are roughly around there, around here, which is ranging from like 52 all the way to 100. And then that the point is like 18 there. And then suddenly this guy, it got 10 points. And then to refer, this one is actually at 27 points. What is the problem here? You input the number that's fall outside the range of your input. Because your range, it's only be very, very accurate around this region, right? Because your maximum input is, sorry, your minimum input is here, your maximum input is here. As so as your maximum output and minimum output. It's your range between here. You finding the result of A from 52 to 100 around here, then that result is most likely correct. But then this one, you input a 10 or it's outside the range of it. So the reason for us to say that using a result of 10 points in test A to infer the result of test B as a 27 point, you can say that okay, the input falls outside the range of test A. Okay, you have another term which is called the this kind of test is a uh, this used the extrapolation. Okay, that means you use this range to predict the thing that is outside of this range. You're finding these things, we call it extrapolation. Okay, which is not that accurate. Okay, and then for those that if you want to know, if you want to find a result between the points that's around here, we call it interpolation. Okay, So now because this one is an extrapolation, that's why it is a wrong, it's an inappropriate word. Okay. So part C, what do we have here? All right, so this person scored on 90 on test B. The teacher estimated his score on test A to be 87 to the nearest integer. Okay, and then see if that one is actually, and then we substitute it back, right? So it's basically they use the result of the B, right? And then find what the A is, okay? And then we have to give a reason why this method is not appropriate. Okay, so again, do you recall the things that we were doing? And that's why we say something is a independent variable, something is a dependent variable. Which one is the independent? It's again we are using the independent A to figure out to figure out the dependent B, right? So that means if you are using the A to find the B, we are happy. Okay? But in this case, you use the same formula, but do it backward. That means directly you have the B here, but you're going backward to find the A. That one is not a good practice. Okay? Because you're using the dependent variable to backward define what the independent variable is. Okay? Which is slightly not okay. So that means for the reason for C1, your reason should be what? Your reason should be because this regression, it's what is it saying? We just use their wordings. It's of test B score on test A. Okay, instead of test A on test B. Okay, so that means you shouldn't use the output to predict the input. Okay, so therefore, it's not appropriate. I know I write a lot though. Appropriate to use test B as the output to predict test A as the input. Okay. So now C2, because we have two parts, right? Use the appropriate method to show that the estimate of test A score for that is 86 to the nearest integer. We have a pretty easy fix. You take a look here. Now, just now, our X is actually the list one. That means the score A's, right? Sorry, that's the test A's, right? The output is list two, which is the scores of test B. Now our job is to just swap these two over, okay? So basically, we can just click in statistics, right-hand side, and then go to linear regression line. We basically just have to swap. Okay, just delete this one, make it the list one, and then go to the top. Okay, delete this one, make it the list two. And there we go. So that means now if we have the test B result, we can have the use a linear regression line of A on B. The linear regression line is y equals to 0.98712 x and then minus 3.2197 okay, and then we're going to replace the x with the what's the score again? This guy got 90 points. So y equals to 0.98712 times 90 minus 3.2197. Use your calculator. 0.98712 times 90 minus 3.2197. So that's gonna be 85.62, which is 86, but then correct to the nearest integer. Okay, so we show that actually that's an 86. All right, makes sense, right? Makes sense. Then we can then move on a little bit. All right, so okay, question 6. Now this is the question that we cannot see in AASL papers. Okay, so which is like it's a unique for AAHL. All right, so question 6, let's say in the happy land, the weather on any given days, it's independent of the weather on any other day. So this one, the probability of raining is actually 0.2. May has 31 days, okay? So probability that it rain exactly. Now, you have to be so careful when you're doing AAHL papers that it sets exactly, okay? Or at least, or these type of numbers, usually it falls into the binomial. Usually, okay? You see these words, you see the probability of something, you see the total number of days. It's a pretty big hint, okay? What is a binomial criteria? It's first of all, you're gonna have the success probability, right? You're gonna have the total number of trials, okay? And then you have your desirable number of trials, okay? So this is the case, okay? Now, do we have the success probability in this case? Yes, 0.2. Binomial means either it works or it doesn't work, right? So in this case, you're gonna have the either it rains or it doesn't rain. All right. So then the next one is the total number of trials, which is 31 days. Okay. Now for part A first. Now exactly on 10 days. So first of all, we need to address that we tell the marker we know that it is a binomial. So that means for the right, the variable is belongs to the binomial of what? Of the 31, and then that's the total number of trials, and then the success probability is 0.2. Okay. So then now we have to find when the probability, right? The probability when this one is exactly equals to 10. So when they say exactly equals to 10, just now when we were doing normal CDF, PDF, CDF means cumulative, okay? Or if I say it wrong, just correct me. But let's put in this case, cumulative, that means you're covering a part of the area. P stands for a point, which is like, for me, it's easier to recognize, to remember. If you have the P, that means you're finding that particular point. In this case, we can then use the uh, do we have anything here? No, we use this one. Sorry. We go back and then find the binomial PDF. Binomial PDF. All right. So the binomial PDF. This is particular point that we're looking for, which is what the n. N is the total number of trials, which is like 31. Put a comma. Success probability 0.2. Put a comma. Exact number of the uh events that we wanted to occur, the occurrence. We press enter. So we get 31, 0.2, and then 10. And that should be equal to 0.041889, which is equal to 0.0419. Okay, correct to three significant figures. Okay. So now it rains on at least 10 days. What does that mean by at least 10 days? At least 10 days means, okay, if you have the number of days, this is 1 day, 2 day, 3 day, and then 8 day, 9 day, 10 days, 11 days, all the way up to the 31st day. Okay, at least 10 days means where should you cut the part? At least 10 days. Is it cut here? No, you should cut it like right there. Okay, so that means here and all the way to the back, these are the numbers that we want, okay? These are the probability that we're looking for. So of course, you can then calculate it by adding all those binomial PDF from the 10 all the way to 31st, okay? Or you can just directly minus the probability starting from, okay, you also have a 0 here, okay? From 0 days to 9 days, okay? So then we can then write it down, the B as what? The B, the at least rain on 10 days, which is 1 minus uh, the probability of X is less than 10 days. Okay, because at least now you have to be very, very careful with this one. Less than 10 days, not less than or equals to 10 days. It's less than 10 days. This one is exactly equivalent to 1 minus the probability of X is less than or equals to 9 days. Because in this sense, what less than 10, it's the same as less than or equals to 9 in this particular case. You see this one clearly. All right. So then now what do you have to do? It's again go to your calculator and then use what binomial CDF this time because a cumulative range, okay, it covers a part. So we go to second vars and then go press top binomial CDF. Okay. So now again, this one is a CDF. It tells you again, you can't input any numbers there. All you can do is you can calculate what is the value it covers up to. Up to the 9, you press a 9. So many people you fucked up because you put in a 10 there instead of a 9. And then you have to use 100% to subtract that. Okay. So make sure you can write down something like these. And then you have to figure out, oh, what is the number that I want? What is the number that I want to skip? The 9 is the last one that we want to skip. And also those that from the front. So that means we are picking the 9. So again, the CDF is actually 31, which is the total number of attempts. And then success probability 0.2, and then we're going to press a 9 there. So which is 92.5%, right? So 1 minus 0.9254. Duh, 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 duh. So again, 1 minus the answer, enter, which is 0.074599, which is 0.07463 significant figure. Okay, make sense? Now part C. The first day that it rains in May, it's the 10th day. It's the 10th day. Okay. So what does that mean? That means that every single time you have to pick a probability, right? Every single day by day thinking process like this. Okay, day one, it rains or it doesn't rain or it rains. Day two, it it rains or it doesn't rain, right? Day three, it rains or it doesn't rain, right? So this process repeats so on and so forth, right? Each day is different. This is day one, day two, day three, all the way up to day whatever. Okay. So it says the first day, it's the 10th day. That means that what does it mean? This implies the first 9 days, it falls into that 80%. Okay. Each day, if we have to choose, that's the 80%. It never rains, right? It doesn't rain, it doesn't rain, it doesn't rain. Because it says 20% is the raining chance, right? That means it had been not raining, the 80%, it is hitting in a row for 9 times already. Okay. So that means what can we write it? It's a C. You have to create the scenario that it has been not raining for 9 days straight already, which is like you are in the streak of not raining to the power of 9 already. 80%, 80%, 80%, 80% until it's 9 times. All right. And then finally, you're going to times the 10th day probability, right? This time, because you want the first day to rain, it's the 10th, right? That means the 10th day it has to rain. At the end, oh, this is 9 days. At the end, between the 80% and the 20%, this time it goes this way. So that means you're gonna times the 0.2 there. All right. Does it make sense? Because it has to go in the streak. Okay. So that it becomes that one. So you use 0.8 to the power of 9 and then times 0.2. You're gonna have what is that called? 0.0268. Yeah, that's it. Yeah. So that's gonna be 3 significant figure, okay? Nothing too special. Question 7. Oh, finally, we are moving on to something that is slightly harder, okay? So we have a differential equation, and then now this one, I think this one is really the sort of like the slightly harder part. You have to recognize a thing first, okay? Which is you see this one, it's dy dx equals to x plus y. If you directly use the conventional way to do it, you can't do it because you want to multiply the x to the dx to the other side, but this side has an x, this side has a y. It doesn't work, okay? So that means you need to recognize a thing. You need to recognize a thing, which is you have to integrating the factor, okay? So again, the things that we can actually do is we have to rewrite it. So dy dx equals to x plus y, right? And then dy over dx, you minus a y that equals to x, right? Which sort of like you're trying to write it in this way first, okay? So 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 um why can we the things that we can do to help us to understand this part, it's we have to multiply a thing called e to the power of negative x, okay? Because this is the integrating factor thing, okay? So that means that again, I'm using a longer approach so that to show you guys what's going on there, okay? So then um, now what you can see there is I'm trying to multiply everything by e to the power of negative x. So then you're gonna have what? You're gonna have e to the power of negative x and then times dy dx minus e to the power of negative x times the y and then equals to x times e to the power of negative x. Okay. Now, if you think a little bit, if you think a little bit first, you take a look at why do we have to multiply this e to the power of negative x? It's sometimes because we cannot do it, we have to think about the reverse process of the product rule. Okay. What is this one? Now, I have something called dy dx, right? I have the original y, and I have the e to the power of x, I have e to the power of negative x, right? So if you recognize this one, that actually it's the what is it? It's the u dv and then v d du, right? And this is du, this is the v. If you can see that, okay? Now du because the negative it's because of the negative x. Okay, you can recognize it, right? So actually, this thing is actually the part for what? It's actually the derivative, the derivative of what? The derivative of the the duv, right? What is the u? The u it's the e to the power of negative x. The v is the y. Okay, we successfully trying to replace it with the things that we see here. That's why we have to multiply that, okay? The details I don't cover too much because that should be part of what your teacher's job to teach you. Okay. I just show you that okay, you please recognize this part. Okay. So then now the next thing that you have to do is okay. After we recognize it, we can write it as d dx, and then actually you put a y first, then e to the power of negative x equals to x to the power of x times e to the power of negative x. Then what you can do is you can both sides integrate it with respect to dx. Okay, with respect to dx. All right. So then now what you can do here it's this part is slightly easier because you can you integrate the derivative that gives you back your original y e to the power of negative x, right? And then to the right hand side, you've just used the integration by parts, which is you can take a look at here. How do you do it? Just u, what is the u? U is the x. What is the du? Du is your one, right? And then first you're going to put the dx there. Okay. And then what is the v? The v is negative e to the power of negative x. Your dv is what? It's actually e to the power of negative x and then the dx. All right. Okay. So then now, after that, you can then assemble the things together. What is that? The integration by part, how can we write it? It's we have to write the, what is that called? We have to write the u, we have to write the what? We have to write the uv and then minus the integral of what of the dv, right? The sorry, that's the dv du. Okay, yep, yep. Okay, So then now the things that we have to do right now, it's sorry, it's only the VDU. Okay. So then we just substitute the things back into it, which is this is the x, okay, and then times for this RV. RV is negative e to the power of negative x, and then minus the integral of what is that? That's what's dv? Sorry, v negative e to the power of negative x, and then the one dx like this. Okay, so which is we use in the integration by part. Now e to the power of e times y times e to the power of negative x is equals to basically this is negative x times negative e to the power of negative x. Okay, and then you gotta subtract because you do the integral for this one. Integral for this one, that means you just find what's the version before you differentiate it, right? So that means it should be itself divided by the derivative of that, which is basically just e to the power of x. Okay, should be e to the power, also e to the power of negative x. Okay, and then of course you're gonna put c. All right, and then now at the end, everything divided by e to the power of negative x. Okay, so then you're gonna have what? You're gonna have y equals to x times your negative one because this part will cancel except the negative. Okay, and then you're gonna be minusing the one plus c. Okay, times e to the power of x actual. Okay, which is y equals to negative x minus one plus c times e to the power of x. Okay, and then finally, we're gonna substitute, right? Because when it is the two for the y, x is a zero. So we substitute. This is a two, and then this is a zero, right? So that's a zero minus one plus c times e to the power of zero. So two equals to minus one plus c. So c equals to three. Therefore, your equation is y equals to negative x minus one plus 3 times e to the power of x. Okay, that's the whole thing. That's the whole thing. All right. So moving on to the next one. Moving on to the next one. Okay. Question 8. Question 8. Continuous variable x has a probability density. Okay, show that basically this is what we can see there. Show that the k satisfy the equation 7k cubed equals to 6. Now this is a 2-point question, which is like pretty straightforward. Now that means every single thing, they combined it. Frequency density, what does it mean? A probability density, what does it mean? That means the density, the area under whatever these, they add up should be equals to 100%. That means exactly equals to 1, right? So let's say part A. What do we have to do? We, of course, we're going to do some integration, which is an integral from 0 to k of this kx. Okay, and then we're going to integrate it with respect to our x plus the, from the k to the 2k of our 2kx minus the x squared dx. And then we're going to make it equals to what? We're going to make it equals to 1. That means 100%. All right. So just now, what have we learned? We have to do the integral, right? So that means, do you still remember? It's the power plus 1, which is 2, divided by new power, and then we're gonna calculate from k and 0. Same as this one, same case, power rule, 2kx squared over 2. Later on, we can cancel out the 2 later, don't worry. And then minus x cubed divided by new power, which is the 3. Okay, again, substitute from 2k to k, and then equals to 1. Don't forget that, okay? So then now if you can just directly substitute the k into it. If you substitute 0 there, that's going to mean nothing. So you don't have to care about that. And then that means the first part is basically k times k squared over 2 minus 0. Plus, now this part is a little bit more troublesome. Okay, so now 2 divided by 2, you can just cancel it out. So that means the first part is k times k, sorry, times 2k whole square. Okay, and then minus the 2k to the power of 3 divided by 3, close bracket, minus the k times the k squared minus the k cubed over 3, like this, and then equals to 1. Okay, write it clearly. So what you're gonna have here, you're gonna have k cubed over 2 plus, what is that here? Now, you distribute a little bit. I use the pink pen to show you. This is actually, don't forget, it's actually 4k squared. So that's going to be 8k squared, right? Sorry, that's going to be 4k cube. So 4k cube minus, again, this one, you distribute the 3 to the 2 to the k, which is 2 to the power 3, which is 8. 8k cube over 3. Okay? Then you're going to minus, oh, gee, a k to the power 3. Use brackets if you don't want to jinx the whole thing and don't want to switch it yet. Okay, so minus the k cube over 3. Gee, wow, I hate doing these. But yeah. K cube over 2 plus. So you're gonna subtract a little bit. You use your calculator lah. 4 minus that. 4 minus that, which is what is that? Actually, 4 minus 1, which is a plus 1, right? Plus now this one, if I take away the bracket, that becomes plus 1. So then these two combined, that's actually going to be 9k cubed over 3, which is like 3k cubed, right? So that means 4k cubed minus, and my plus, so that's a 7. Gee, I was wrong this one. Okay, my bad. Okay, so that means that's actually, okay, 4k cubed minus 3, so we only have a 3k cubed there. And then mine is actually not as 9, but as 7k cubed over 3. And then equals to 1. Okay, now you can then try to multiply everything by the common denominator of 6. Okay, so that means everything you times the 6 on both sides. Because why? Because the least common multiple for the denominators in 2 and 3, which is a 6. So after we do that, we're gonna have 3k cubed plus the 6 got distributed, so we just got 18k. That's an 18k cube. Minus, that's going to be 2 times 7, because 6 divided by 3 is a 2. 2 times 7 is 14. 14k cube. That's equal to 6. So 3 plus 18, which is 21. 21 minus 14, that's 7k cube, equal to 6. We proved that. Okay, G. All right, find the median. Find the median of x. So how can we find the median of x? Is we can do it in a particular way, which is now. Since I said it, this one is a now. If we use the understanding like this, okay, the area of everything here is equals to 100%, right? Okay. Then what does the median mean? The median means exactly 50%. Because like median of the probability is it 50%? It is, right? So that means we are trying to find the 50%. The 50%, we are not finding the middle of the x-axis of the range of the values. We're finding what is exactly the area that it occupies for 50%. Okay? So that means we don't have this particular point. So we are looking for from 0 to this particular point, and then the integral between this particular curve, under that, it gives us the 50%. Okay? So that means we have to set it up first. So is it part C or part B? Actually, part B only. It feels like a 3-part question though. So we're integrating from 0, let's say, to A, let's say, okay, of this equation, which is what is the equation? We don't know, but then that's actually gonna be 50%, which is km. Is it km? Yeah, km, and as a kx, sorry, kx, and then dx, we have to make it equal to 0.5. Okay, so that means k k Oh, but we have to calculate what the k is first of all. So that to check if that's actually uh do we need to find a little bit more of the points first? Okay. So 6/7, and then we have to take the cube root for that. So take the where's the cube root? Never mind, we can just take the to the power of 1/3. That's also the cube root, which is 0.9 something something. Okay. So we first of all need to do a little bit of rough check first, okay? So that means the k is equal to 0.9499143, okay? So we're gonna check if we integrate from 0 to all the way up to the k, if that one is actually cover up till 50%, okay? So 0 to 0.949499, and then just do a little bit of checking first. So 0.9499 times the x and then dx. Okay, we're gonna check it quickly, math, and then go to number 9. And that's actually gonna be 0. This is 0.9499142.516, and that one is 0.9499142.516 times the storage. Oh, now you see here, this is 42%, right? This is 42%, right? That means if 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 we have to calculate this part directly equals to 0.5, that doesn't make sense because the k is limited to the maximum for the first part is actually is equal to 0.42857 only, which is not 50% yet. That means, okay, it is a piecewise function, right? The first k, it lies in here only. That covers until like 42%, which is 0.428. We still have to figure out the extra mile here when it is from the 0.9499 up to this point of the second part of the equation, okay? So what is the thing we have to do? Then we have to write it out like this. Okay, first of all, we have to show that, okay, now we integrate 0 to the first of all, we're going to show the k equals to 0.9499, right? And then uh, integral from 0 to k of our kx dx is equal to 0.42857 dot dot dot. Okay, so then now our job to figure out what is the exact median for that, it's we're gonna write like this: from 0 to the k of the kx dx plus from k to the our point a. This a is the unknown that we're trying to find, okay? And then of our the second equation, which is 2kx minus x squared. 2kx minus x squared dx equals to 0.5. Okay? Equals to 0.5. Write it better. Okay. Because we just figured out that this particular part it's 0.42857, right? So that means we can then rewrite it this one as what? Actually 0.9499 up to the a of our 2 times 0.9499. All right. And then times the x, and then minus the x squared, and then the dx is equals to uh, basically 0.5 minus the 0.42857, right? Okay. So then, now everything is still like solvable, but except you need to use a little bit of the work to do. So we're gonna use 0.5 minus our answer, which is 0.07. This is equal to 0.0714. Okay. So if we calculate that a little bit, we can then have the integral result back um back here, which is 3 minus 7/3, which is like 2k. uh, okay, so we just calculate that quickly. We're gonna have what is it? So that's gonna be, gee, I don't want to calculate this. So if we write it out, we're gonna have 0.9499 x squared, okay? And then minus the x to the power of 3 over 3, right? And then this one, we can then calculate it from a to our 0.9499, and that equals to 0.0714, okay? So then now, basically it becomes an quadratic equation to do, okay? So we can then input the 0.9499 a squared minus a cubed over 3, and then minus the 0.9499, that's actually to the power of 3 already, minus 0.9499 to the power of 3, and then divided by 3, and then make it equal to 0.0714, okay? So what does that give us? Now we can then use the graph, or we can then use, can we use the solve? Do you have the solver? This one is not included, but never mind. We can use the most basic thing to do, which is 0.9499 times the x squared, and then minus our x cubed divided by 3, and then of course we're going to bracket it, and then minus our 0.9499 to the power of 3, then minus the 0.9499, sorry, to the power of 3, and then divided by 3, okay? And then close bracket, and we're gonna minus the 0.0714. Yeah, to graph it up. So then we can trace a little bit. What is our M? So what is our A? Okay, so that means we can solve it by our calculator, which is the A is equals to 1.02921, okay? So which is A equals to 1.03, okay? Finally. Do we have any specific things to list it out? No. So that means it's equals to that. All right. Yeah. If you have quicker method, you can just use it, because I have to show you all the work here and we use a little bit longer time there. Okay. So all right. Question number 9. Question number 9. Question number 9 is a permutation question. Okay. So let's read the questions together. So now a group of 10 children, including a pair of brothers, A and B, and a pair of sisters, C and D. They have to sit on the 10 desk. Find the total number of ways that the children can be seated. Okay. Now A and B has to be seated right next to each other. Each other. Okay. So what does that mean? What does that mean? Okay. If these two, and they can't be seated in the front and back, right? So that means you can only have this, or like this, or like this, or like this. Can it be? Can it look like something? Looks like this? It cannot. So that means now you can have 1, 2, 3, 4, 5, 6, 7, 8 first. Okay, you can already have 8 ways to arrange these two guys. Okay, so you already have 8 ways. So that means that number A, we're gonna write it 8 ways. Multiply multiply. Now, assuming that they have occupied like 2 seats, any 2 seats, okay? What is the rest of them? The rest of them, we got 8 seats, right? How can we arrange the 8 seats? Those 8 seats can be arranged by what? Can be arranged by, uh, can be arranged by the, not, combination, but permutation. 8 people arranged by 8 seats, okay? And then it is not done yet because within the brothers, they also have two ways to do that, right? So it could be A this one, B this one, or B this one, A this one. So within every single combinations of these 8 pairs of seats that they can sit together, you also have to multiply further by 2. Okay, so you can use that. That means we're gonna have 8 times. Sorry, we're gonna quit it first. We're gonna have 8 times 2. 8 times 2 times the permutation of 8 people. So we can then use the math numbers probability. This one, which is we times the what times it by what times by 8p8. Enter. So we're gonna have the answer of 645,120 ways to arrange them. Okay, make sense? So part B. Part B. After an argument, C and D must not be seated to each other, and A and B must be seated to each other, right? So find the total number of ways that the children can be seated. Can be seated. Okay. So now, the thing is, we have to total, right? Basically, we subtract the cases. We are trying to subtract the cases of C and D sitting together. Okay. So basically, it's 6, 4, 5, 1, 2, 0. Subtract C and D together, right? That's the thing that we want. Okay. So how can we know it's we can then analyze a little bit first. How can they be seated? So there are how many ways that we can think it like this. When A and B sit at the corners, it is easier to calculate, right? So this is A, B. If they sit in the corners, then that's going to be easier to do because the style pretty much looks like this. Okay. But first of all, there are how many styles that A and B sitting together at the corner? It's gonna be basically we just draw it out, right? 1, 2, 3, 4, and then because each of them they can swap the positions within them, right? So actually 4 times 2. So you're gonna have when they're at corner, when they're at the corner, at A, B at corner, you're gonna have what? You're gonna have 4 corners times each of them. You're gonna switch it up first, okay? Of course, then you're gonna multiply each of the situation. How can the sister be seated together? Okay, so how many ways that they can be seated together? We can just actually circle it. They can just like 1, 2, 3, 4, 5, 6. Okay, which is you can times 6. But then again, this within these 6 pairs, each of them they can actually swap the position. For example, it could be CD or DC, right? For each of the sets of these 6 pairs. So that means you're gonna further times 2. Okay. So now after these 2 sequence, we secure actually 4 seats, right? We arrange the AB, we arrange the sisters together. So there are actually 4 seats got occupied. The remaining 6 seat, then you can then use the permutation formula, which is like the 6p6. Okay, that's what happens when you have AB at the corner. Okay, and when AB at the corner, also with CD seated together. Okay, this is the number. Okay, now in another sense, what happened if AB, that means the brothers, they're seated not at the corner but at here. So there are how many ways? There are 1, 2, 3, 4, 4 ways. Okay, that means A, B. Right. Let me write it out first. A, B, at the center seat, and then C, D seated together. So you're gonna have the 4 ways, and then times the 2 arrangements for the A, B. Because again, 1, 2, 3, 4. That's the 4 here. The 2 stands for the A, B swap positions. The A, B, B, A swap position. Okay, so that's gonna be it. Okay, so now we consider one of them, one of the solution, one of the styles. Okay, so if it's seated like this, basically the rest of the 7 ways, they are pretty much the same thing. Okay, how can the CD be seated together? Let's circle it. They can't fit it there, so only got 1, 2, 3, 4, 5. Okay, so that means you're gonna times the 5 times the CD seat together, and then each of the pair, they can also swap the positions between CD or DC, right? So you're gonna times the 2. And again, remaining 6 seat, you're gonna times it by the 6p6. All right. So that means the CD together, you're gonna have basically two styles, right? Which is when the AB at the corner and AB together, right? And AB together, right? So then now what can we do? We're gonna have 6, 4, 5, 1, 2, 0 minus the AB at the corner, which is 4 times 2 times 6 times 2 times our 6p6, right? Which is like this one. Okay. And then we're gonna minus the other version, which is AB at the center seat, which is again the 4 times 2, but then times 5 styles times 2, and then times the remaining 6 people arrangement. Okay, so now we can then calculate it. You can actually calculate in one go. So, but I just want to calculate 6 times 2. That's for 4 times 2 times 6 times 2 times what's that, math probability, and then 6p6. Okay, and then what is another one? 4 times 2 times 5 times 2 times, again, math. Right. Probability and NPR. This is 6p6. That's going to be that. So we write down the answer: 645,120 minus 69120 minus 57600. And that's going to be this minus this minus this. So which is 518400. That's it. Okay. Moving on. All right, finally, we're going to part B. Now, part B, we did the same thing quite a long time ago before. Okay. Again, it is on our AASL questions. Okay. So we have 3 more questions to go, but that should be pretty chill, pretty easy. So let's start. So again, you have a sine function. All right. You have a sine function, and then you're gonna find the time between the first low tie and the first high tie. So the low tie is 0.5. Basically, you're gonna mark it down first. And then this is gonna be 0.5. That's the lowest. All right. And then okay. So now, what do you have to find? The length between the first low tie and the first high tie, which is like this particular one. What is the first low tie? It's actually right there, right? So, which is like right here. That's the first low tie. That's time number 1. And that's the first high tie, which is time number 2. We're gonna find the peak first, okay? So, there are 2 ways. Either you can just use the graphical function on your calculator to just like sketch the graph and find the lowest point, highest point. Or I think that one is too easy, but I just give you another alternative, which is like this. Part A. The low tie, what does it mean? The low tie means at the minimum, because this is actually undergone a bunch of like stretch, shift, and then compression, whatever. Okay. So, but then one thing it doesn't change is when it is at the bottom, this sine function part, only particular this one part, that will be equals to -1 at the minimum, right? And for sure, that will be equals to +1 when it is at the maximum, right? And we're going to use these two to solve for it, okay? So let's just copy down the function first. What is the function? That's going to be, what is the function? So we're going to be at the minimum. We can then write down, just copy down the sign is okay. Sine of 0.513 and then t minus the 8.2, close bracket, equals to -1. We can then try to solve for the t in this case, okay? So then let's use, make sure we're in the radian mode, okay? We're in a radian mode. So that's gonna be, what can we do? We can use, first of all, inverse sine of 1, that's gonna be, oh gee, what is this? Inverse sine of 1. I forget it. So we can then sketch it out first. Sine function looks like this when it is at the -1. This is the pi, right? This is the pi over 2. And uh, and then this is going to be 2 pi. That's going to be 3 pi over 2. Okay, so then now 0.513 times t minus 8.2. 8.2 equals to 3 pi over 2. Okay, or you can just directly use the number from we see here, sine inverse of -1. Oh, and then we have to add a period there. Okay, but never mind. So now we calculate this one. We can directly use either you use this value or you can use a negative pi over, is it pi over 2? Yeah, pi over 2, negative pi over 2. Then I have to think about this low number first, okay? Because it shift to the where? You think a little bit, this is shift to the right, right? So that means after it shift to the right, then this is what happened. So originally this is where it starts, right? And because it shifted to the right, that's why how it appears to here. So this one originally is from the negative. So we're gonna use the negative version, the negative pi over 2. We're gonna use this one, more preferred. Okay. But again, you can still use your calculator value. So which is times your, we just simply not write this one yet. So which is t minus 8.2 is equals to negative pi over 2 divided by 0.513. And so we're going to divide by 0.513. Sorry, this one. This one divided by 0.513, enter. So t minus 8.2 is equal to negative 3.06198. So t is equal to plus the 8.2, which is 5.13. Okay, 5.138. 5.138 there. Okay, so that's the first point. Okay, and then the next one, or we can just copy down a little bit more digits. Okay, and then the next one at the maximum. At the maximum, so the sine of the 0.513 t minus the 8.2 equals to positive 1. So that means that should be equals to, just now we figured out that's pi over 2, right? Again, 0.513 times t minus 8.2. That's it. So we calculate quickly. So then the pi over 2, which you're going to have pi over 2, and then divided by 0.513, and then plus the 8.2. That's actually going to be 11.26198. And what is it asking for? They're asking for to find the high tides and low tides is 6 hours and 10 minutes. So we figure out the difference first. So 11.26198 minus 5.138. That's equals to I'm subtracting 5.13. That's actually 6.12396. So which is what? Which is 6 hours and 0.12396 times the 60 minutes. So we just minus the 6 first and then times 60. Convert it to which is 6 hours and 7.4377 minutes. Okay. Therefore, your m is equal to 7 because it's correct to the nearest integer. Okay. Okay, so moving on to part B. Part B. What are we looking for? Let's read the question together. Between the two consecutive high tides, determine the time in hours for which the height of the water is less than 1 meter. What does it mean? It means that what is the two high tides? It means like right there and right there is the high tides, right? So between these two, we have to find the amount of time that it's below 1 meter. First of all, we need to set where's the 1 meter. So the height is a 1 meter, then we can draw a line like this. So which means right now we have to find the intersection point of this and this. And after we figure out these 2 points, and then we can find the length of time between them. Okay, that's what we have to do. So essentially, the first thing we have to do is we need to recognize it is the sine function has to equal to 1. Then we have to make sure we're in the radian mode. And then now we can input our equation into it. What is our equation? It's 1.63 and then times the sine function of 0.513 and then open bracket, which is, we use x in this case. So alpha storage and then minus the 8.2, close bracket, and then plus 2.13. Okay. And then the second one, we have to input the 1 there. Now we can graph it out. Okay. So if we zoom in a little bit, the high tides are actually between D here and here, right? So our job right now is to figure out where are these 2 points. So we can use the function trace, and then we can use second and then trace, and then find the intersection point. So set the left boundary as right here, and then enter. So the first boundary we can see here, it's here, which is 3.5692. So we can mark down the graph. Here it's like 3.5692. Okay. And then the second one, again, we use second, trace, and then go to intersect. On our calculator, set the left boundary as right here. Cover the second point of intersection. The second intersection point is 6.7068. So this is 6.70684. Okay, let's just mark it down there. So solve for this one, then we're gonna have what? We're gonna have the time is equals to, we copy down the answers, which is 3.5692, 3.5692, or t equals to 6.70684. Okay, therefore the duration of the time, it's the length of time is it's 6.70684 subtracting 3.5692. Okay, which is we use, of course, we're going to use calculator. 6.70684 minus 3.5692. Okay, which is 3.13764 hours, which is 3.14 hours, correct to 3 significant figure. Okay. Part C, find the rate of change. Oh, this is quite easy at time equals to 13. So I just put it here. Part C, which is when the you have the differentiation at 13. So which is you can input it again your math and then the nth derivative. Okay, so the dx of the whole thing, which is you input a calculator, 1.63, and then times the sine of open 0.513 open bracket alpha x, and then minus the 8.2 close bracket, and then we can plus the 2.13, and then at the x is 13. So we can then have the answer as negative 0.6506. Okay, that's it. Gee, we shouldn't take too much time for this one, but yeah, because of the calculation for when the h of t equals to 1. You use the graphical method and then find the intersection. That's the easiest, okay? All right, so question 10 continues. Question 10 continues, then you can see it asking for something. On the same day, again, you have to model another sine function. If I were you, I want to die. The first low tide is 241, which is the height is 0.4. The first high tide is 902, the height is 2.74. Find the value of A, B, C, and D. Okay. See. So we have to first sketch it out how the graph looks like. So then the first low tide, it's at 241, right? 241. We then later on going to change it to the decimal of like 2 hours and something, 2 point something, okay, instead of 241. And that one happens at the low tide, which is 0.4. Okay, that is. Then we have the what? We have the high tide of 9902, right? Which is at the 2.74. So 2.74, like this. Okay. So you would expect the graph to look like somewhat like this. Okay. So then now there's a few things that we can calculate it first. Okay. Which is now if we draw this one, we also have to draw the middle line first. Okay. So roughly, where does it start to move? Is that you compare the original sine graph looks like this, right? That means it start to have a trend of going up first and going down. So that means from the middle line, it going up first and going down. That means it's actually shifted to the right by this far, pretty much. Okay. So then now let's figure out what the D is. The D for part D, our D is can be modeled by the maximum plus the minimum divided by 2 because we want to find the average middle line, right? So which is 2.74 plus 0.4 divided by 2. 2.74 plus 0.4 enter divided by 2, which is 1.57. Okay. So then what is our A? Our A is actually in another sense, which is like the maximum minus the minimum. Minus 0.4 and then divide by 2. We're trying to find the magnitude. That means how far it fluctuate up and down. Okay. So what is this one? That's the A, right? So then it's 2.74 minus 0.4 divided by 2, which is 1.17. 1.17. Okay. So this is pretty let's say a straightforward. Okay. So then now we have to assume a thing first. Okay. Now between this low tide and high tide, how far or what does it represent the it represent how much of a period from the high tide to low tide. This one actually represent half the period, right? This is half of the period. Okay. Okay. So that means we have to find the duration and then times it by 2 to have the full period first. Then we can use we can use the the equation of period equals to 2 pi over b to calculate that. Okay. So first of all, let's calculate what is the time. Okay. So the time between the low and high tides, it's what? It's actually 9 hours and what? And 2/60 minutes, subtracting 2 hours and 41 over 60 minutes. Okay. We just put it into the decimals first. Okay. So that means 9 plus 2/60 minus 2 plus 41 over 60. So that's going to be 6.35. Okay. So 6.35, that's going to be 6.35 hours. This is also half period. Okay. What is a full period? Because now you think about that. Okay, from high, low, like this. Okay, this is a complete period, right? So that means from the high to the low, this part is actually taking account for this particular way, which is exactly the same as these two combined, which is exactly half the period. So then a period that means actually 6.35 between the high tide, low tide times two, which is 12.7. Okay. So again, we have the formula of period equals to 2 pi over b. So that means b equals to 2 pi over the period, right? Which is 2 pi over the 12.7. So 2 pi over the 12.7, that's equals to 0.494739 da, 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 da. Okay? So then, yep. And then now we want to figure out what it's the how far it shifted, right? So from the graph, we figure out that okay, actually, it's actually shift the midpoint from the original point all the way up to the midpoint here. That means that's the original start. That's the original starting point. Okay. So that means assuming that this is a perfect sine function, This point lies right between these 2 points then. Okay, this is half. So we just take the average between these two, then we can have the C point, okay? So our C is actually calculated by, okay, 9 and 2 over 60. And then, of course, we're going to find the average, right? So we're going to plus the 2 and 41 over 60. And then we're going to times the 1 over 2, okay? We just find half of it, okay? So we're going to use basically, let's just calculate this one, except we replace the minus with the plus, and then divided by 2. Then we're gonna have 5.85833, okay? Okay, finally. So okay, this is what we calculate for part D already. We calculate the A, B, C, and D. When T equals to time, the height of the water, it's the same as that for the first time, okay? Find the value of T. So this one, we can just key into our calculator to figure it out, okay? So basically, what you can do, it's you can just find using the graph. So where's the graph? This one. Okay, so we have the first graph, but we don't have the second graph. The second graph, it's 1.17 times the sine of the B. The B is 0.494739, and then times our X, and then shift to the right by 5.85833, close bracket, and then it goes to the outside, and then we can plus 1.57. Okay, so graph it out. Let's find the intersection point for the first time. And trace. Calculate number of 5 in the intersection. Left bound, let's just set it as right there, and then the right hand side is right there. Okay, the intersection, it's 4.16 for the first time, right? Yes. So that means time is equals to for part D, or part E, that one is time is equal to 4.16. Okay. Yep. Okay, moving on. Question 11. So basically, we have a graph, and then we have this one. We have to show that it's in this case. And we also have this one, right? So we attempt to do the differentiation first, okay? So part A. At this point, you can feel that I don't want to like talk too much, because that's a pretty tiring process for every single student. I think it's x squared plus y squared. So we attempted by differentiating both sides, right? So derivative d dx of what? Of the e to the power of x plus y, right? Equals to what? Again, you're gonna attempt to differentiate d dx on the x squared plus y squared, right? So now we have to use the chain rule. Okay, we're gonna use the chain rule quickly. So we can then have what? We can then have derivative of the top, which is 1 plus the dy dx, right? Times itself, which is e to the power of x plus y, right? That's the derivative. Okay, and then the right hand side is easy, 2x plus, again, the chain rule, we differentiate the y square first, put the 2y to the front, which is 2y, and don't forget, because it is not the native of the x, so we're gonna write it as dy dx as well. Okay, so then what do we have to do? We have to basically just make dx dy the subject. That's okay. So we distribute it, we're going to have e to the power of x plus y plus e to the power of x plus y times the dy dx equals to 2x plus 2y times the dy dx. Okay, we move the things over. Basically, we're trying to group this and this together. And then the rest of them, this goes to the other side. Okay, and this goes to here. So then we're going to have e to the power of x plus y times dy dx minus 2y times the dy dx equals to 2x minus e to the power of x plus y. Both sides have the common dy dx factor, take it out of them. So dy dx equals to e to the power of x plus y minus the 2y equals to 2x minus e to the power of x plus y. So dy dx is equals to 2x minus the e to the power of x plus y over e to the power of x plus y minus 2y. Okay, that's it. And this is how we can show the things. Did we cover anything right? Yep. So that's the part A. All right, part B. So that's the x and y equation satisfy this one. So this one, how can we make it satisfy? It's we basically can see that these are two uh, flat points, right? That means the stationary points. That means the dy dx equals to 0. So we're gonna write like this. So part B, okay, so that's the part A. We're gonna make dy dx equals to 0. So basically, when we make dy dx to 0, that means the bottom is actually no longer applicable because both sides multiply by this, then it's gone, right? So we can then directly write 2x minus e to the power of x plus y equals to 0. The problem is we need to show that what is exactly like this, right? We need to show what is exactly in this particular format. We see no y's. We see no y's, right? So what can we do? We can then have to just write it 2x equals to e to the power of x plus y. There's nothing else that we can do. We attempted to solve for we make y in terms of the x. So natural log of 2x, natural log of this. So we're gonna have, and then we'll bring the power down. So we're gonna have natural log of 2x equals to bracket x plus y times the natural log of e. The natural log of e is equals to 1, so we don't have to write anything. So y will be equals to the natural log of 2x minus the x. Okay, this is the things that we want. Now, what do we have to do? We have to plug it back into our equation. All right. So how does that do? So what is the original equation? That it's e plus e to the power of x plus y equals to x squared plus y squared. We copy it down first, which is e to the power of x plus y equals to x squared plus y squared, right? Now we have the y from what we did in part B just now. So we can then replace the things. E to the power of x plus natural log of 2x minus x equals to x squared plus natural log of 2x minus x whole square, right? So this part's a little bit different because x minus x, these two can be cancelled out. So you're gonna have what? You're gonna have e to the power of natural log of 2x. So you remember e to the power of natural log of something that's basically becomes itself again, which is whatever this is, you just copy it down, that's 2x, right? And then the right hand side, you just expand this one a little bit, which is the natural log of 2x whole square plus 2 times the x times, sorry, minus, because that's a minus, 2 times the x times the natural log of 2x, okay, and then plus the x squared, okay? So then you group the like terms together. Where the like terms is x squared and x squared, you group these two together, all right? And then move this one over. So you're gonna write it as 2x squared and then minus 2x natural log of 2x minus 2x plus natural log of 2x whole square, like this, and then equals to 0. See if that actually fits to our solutions. Yeah, you see, it should be exactly the same, minus 0. Okay, except the order is a little bit different, but it doesn't matter. All right, then we try to figure it out. What is the exact answer for part? What is that? That's part B1. Gee. So part B2. Again, we go to the graph. We just clear everything, and then we just basically input this one into it. So 2 alpha x squared, and then minus 2 alpha x And then where's the natural log? Natural log of 2 alpha x. Okay, minus 2 alpha x. And then plus bracket natural log of 2 alpha x, close bracket, squared. And then let's see the graph. Okay, so now we want to find what the zero is, right? So then we can then have we basically have 2 points. So let's just a second calculate the zero. So left boundary, the first point we're gonna find is basically from here all the way to here. So the first point is x equals to 0.33108, or x equals to then second trace 0 left bound enter, that's actually 1.84273. Okay, so correspondingly, what is the y? The y is equals to this, right? Which is the y equals to, what is that? Natural log of 2x minus x. Natural log of 2 times 0.33108 minus 0.33108. Okay, so correspondingly, let's quit it first. So natural log of 2 times 0.33108 close bracket minus, minus 0.33108. That's like negative 0.7433. Okay, and then what about the y? The y for another one, which is the natural log of 2 times 1.84273, and then minus the 1.84273, which is 0.53 uh 53 538 538 833 okay, something like this. Okay, so therefore you have two sets of coordinates, which is 0.331 comma negative 0.743 and 1.84 comma 0.539. Okay, or 538 lah, doesn't sorry, 538, sorry, this should be just a 3. Okay, all right, so then oh, we have to label what is a p. The this is basically the p. This is basically the q. All right. Okay. Part C. Part C here, it asks for what? It asks, using the line of symmetry, write down the coordinates of the points of the points on the curve C where the tangents are vertical. So which is like this point, right? Which is like this point, right? If we have to find this one, that means the curve C is a vertical. You have two vertical asymptotes, which is sorry, two vertical tangents, right? Which is right, one is here and one is here. Okay, and if you can see that clearly, it's actually the mirror image of that. So the P coordinate essentially just swapped it to here. Let's say this is the XY, then the coordinate here is going to be YX, right? The Q coordinate is corresponding to here. So if this is like XY here, again, this is going to be YX, okay? So now we found out that the P coordinate is this. That means the coordinates of the vertical tangent is just going to be the X and Y swap the positions, okay? So we can then say the coordinates are, so we just swap it around. The y coordinate, we write it as the x coordinate, which is like negative 0.743, comma, and then put the x in the y position, which is like 0.331. Okay, and what? The next one is, again, we put the y coordinate of the q as the x coordinate of our answer, and then 1.84 as the answer. Okay, that's the answer. We can write it down like this. Okay, so okay, sorry, we missed out the negative here. We should put a negative here. Negatives. Okay. Yep. That's going to be the answer as of now. All right. So then now let's move on to part D. Move on to part D. Part D is, okay, find the coordinates of the point of the curve C where the tangent has a gradient of -1. Now, it says tangent of gradient 1. Then what does it mean? Gradient of -1, that means the dy dx has to equal to -1. Okay? So which one does it tells us that dy dx is -1? We copy down from our part A. So essentially it's we copy exactly this one and then make it exactly like equals to -1. So part D, we write it down first, which is the dy dx equals to -1. Then we copy down our dy dx, which is the 2x minus e to the power of x plus y over e x plus y minus 2y equals to -1. You move the things over, you're going to have 2x minus e to the power of x plus y equals to negative e to the power of x plus y minus 2y. So if you separate a little bit, negative e to the power of x plus y plus the 2y, that will be the exact answer. So you duplicate that, then you can actually cancel two things out. This one and this one. They could be both canceled out, right? Because they are the same. Now, then you reach the conclusion of 2x equals to 2y, which means x equals to y, okay? Now, if we reach out this condition, that means when the gradient is -1, the x coordinate and y coordinates, they are equivalent, they are the same. So now we have to use the original points to figure out what is the x and what is the y, okay? So use the original equation. What is the original equation? The original equation is this, right? E to the power of x plus y equals to x squared plus y squared. So let's write it down. E to the power of x plus y equals to x squared plus y squared, right? Okay. And now what can we do? We can then write it as, okay, e to the power of basically x plus x equals to x squared plus x squared, like that. So e to the power of 2x equals to 2x squared, like this. All right. So for this one, you can actually use your calculator to solve for it. Okay. So since we don't have the pro function in here, but we can still figure it out. Okay. So let's go to the graphing functions. Okay. And then let's go to here, and then let's clear the first one. We input the first one equation as, where's the e? Where's the e? E. Second e to the power of 2 and then alpha storage x, okay? The second equation, we just simply input 2 times x and then square like this. Look at the graph, okay? Now, if you use second trace and then find the intersection point, then you try to find the left boundary. Let's do from the left-hand side all the way from here, enter, and then all the way to the positive, since if it's to the positive, it never intersect. Okay, so now you can see here, they have the intersection point, which is when x is -0.4506. So the x is equal to -0.4506, like this, okay? Since we have the conclusion that x is equals to y, that means because x equals to y, so then the y also equals to -0.4506, okay? So therefore, the coordinates, the coordinate are -0.451 because of three significant figure and -0.451, okay? Now that's it for question 11, okay? Now question 12. Question 12 is a slightly tricky. So we have to use we actually don't have to have the full concept of vectors, okay? So basically you just follow the formula booklet. That should be enough, okay? So now let's see part A. Use the definition of u times v and then the u times v, okay, in terms of absolute u and absolute v and the zeta, show that this equation, okay? So how can we prove that, okay? So if you go to the formula booklet, you can actually figure out two things. okay, we can then see here. Can you see this one? This is the times, right, with the sign. And where's the dot product? Here, dot product is this one, okay? So we're gonna use these two things to help us to do it, okay? So now let's write it out, something for us to write down. So the dot product V times W, okay? What is it equals to? It equals to the absolute V times, we say absolute, okay? Easier to understand, okay? You know what I mean. And then times what? The dot product is gonna be times the cosine theta, right? Whereas just the product of V times the W, like this, is equal to absolute V times absolute W, and then times the sine theta, okay? If you don't understand what is going on here, it's totally fine because you can simply use your mathematical skills to write it out, okay? So now that we have to prove this one works, the left-hand side equals the right-hand side, right? So let's just write it down first. Part A. So u dot v close bracket square, and then what is the question again? Plus absolutely u times v whole thing square. Okay, so let's try to write it out first. What do you have? Okay, the dot product, we just copy down the whole thing. Okay, which is the absolute, and sorry, we have to use bracket in this time. So it means absolute u times absolute v times the, what is that? It's the cosine, right? That's the cosine theta square. Okay, and then plus what? This one, it's the absolute u times absolute v times the sine theta close bracket square. Okay, that's the case. All right, so then now if we have to expand it a little bit, what can we see? You're gonna have something like this, which is absolute u square times absolute v square times cosine square of theta plus absolute u square times absolute v square times sine square of it. Okay, so from what you have learned about factorization, which is like a basic math question, you can extract the common factors of these two. Extract them out first. Then you're gonna have what? You're gonna have absolute u square times absolute v square again, and then left over with the cosine square plus the what? Plus the sine square. And with a little bit of the trig identities, you understand that this one, that's equals to 1. So which is equals to u squared times the absolute v square, okay? So this it, yes, then that's gonna be the conclusion, all right? So then now let's take a look at part B. Triangle ABC has a vertices like these, okay? And then U is the AB, V is AC. Now, for questions like this, my own practice is just randomly sketch it out first. I don't care about where it is, but just write it out first. So let's say this is pretend is in this way, okay? So let's say this is A, that's B, that's C. So just follow the instruction of what they're gonna give you, okay? It said U is AB, you just write the U here, U, and then V is AC, you just write this one as a V, okay? It's to visualize the things so that you can see clearly on what's going on, okay? So now, and you have these things, right? Okay, given that you a dot product V is 3, and then the area of a triangle is like this, find the value of this. Okay, how can we find that? How can we find that? Okay, so we have learned one thing, which is the area of a triangle, right? How can we find the area of a triangle? It's by what? The area of a triangle, it's half AB sine C, right? That's the thing. Okay. So now we make use of this one. Let's say write part B1. Okay. So the area of the triangle ABC is equals to root 6, right? Which means that we can also use the formula, which is the half of what? Actually, it's a half of, if you see this one clearly, that's going to be the U, that's going to be the V, right? So these two multiply together, that means of the U times V, okay, half AB, and then sine of the theta, okay, of the theta angle there is equals to root 6, okay? Hey, with the things that we just observed there, can you see here? Hey, the product, we can actually write it as the V times W, okay? As a product like this. So then we can actually replace what? Replace this batch as 12 times what? Times the V times, sorry, U times V. Just follow what they use. U times the V, like this. And then equals to root 6. So clearly, the answer we want is equal to 2 root 6, like this. Okay? Nothing else that you have to write. Okay? You don't have to use the fact that it is a 3 yet. Okay? Hence, or otherwise, find the value of absolute U. Find the absolute U. Okay? So now, this one is a little bit of slightly tricky. Okay? And we might have to use the things that we found out here. Okay? So basically, can we actually figure out what is a U and what is a V first? Actually, we can figure out what is a V first of all, okay? Which is 3 minus 0, 2 minus 1, and then 1 minus 2, okay? So let's just write it down first. So B2, let's just write down the V vector. What is a V vector? It's what? It's actually, I will write it better, okay? It's like 3 minus 0, 2 minus 1, 1 minus 2, which is equals to what? 3, 1, negative 1, right? Okay? So then now, if we want to find the length of it, of the V factor, we can then use the formula, which is like the 3 square plus the 1 square plus the negative 1 square, right? Which is the square root of, that's a 9, that's a 1, that's a 1, right? Which is root 11. Yep. Okay. So then we use the things that we found in part A, which is the dot product thingy. So U dot V whole square plus this one is a product between V and U times, sorry, U squared, okay? Okay, and then we write it in the correct order, first of all. Otherwise, it will be wrong, okay? U times V, okay? And then equals to what? Equals to this U square and then the V square, okay? So now, what is our unknown? Our unknown is the U, right? It's a U. We would like to figure out what this is. That is our unknown, okay? But at the same time, we have this one, right? Because this one is equals to 3. This one, we just figured out as what? It's 2 root 6. This is from part B1, right? And then this one, we just calculated only this particular part is a root 11 because we just figured it out from here, okay, which is root 11, okay? So then now it's pretty clear. You just substitute and then solve for and make absolute U the subject. That's it, all right? So then you're going to have what? You're going to have bracket 3 squared plus the 2 root 6 squared equals to absolute U bracket squared times the root 11 squared, okay? So you're gonna have 9 plus what is this? This is 4. 2 squared is a 4. Root 6 squared is a 6. 4 times 6 is 24. 24 equals to absolute U squared times now root 11. 11 squared, which is 11 only. Okay. So that means that's gonna be 30. That's gonna be 33 divided by 11, that's equals to absolute U squared. So 3 equals to absolute U squared. So absolute U is equal to root 3. Okay? Again, pretty straightforward for this one. Okay? Now, part 3, B3. Hence or otherwise, find the possible value of P and then the corresponding values of Q. Now, this one, it is again, it is a little bit special because we need to figure it out what it's the vector first of all. Because just now we figured out the V, right? But we didn't know the U. What does the U look like? What does the U look like? The U looks like what? It looks like from B to A. Sorry, B minus A, right? Which is like the P and then the Q minus 1 and the 3 minus 1, which is a 1, right? Okay, that's the vector of U. So we write this one down first, okay? So we might have to add another piece of paper, that page. All right. So now let's write down B3, B1, 2, 3. Okay. So let's write down U first. What is a U? We just copy down from what we have written, which is the P and then P and then Q minus 1 and then 1. So P, Q minus 1 and then a 1, like that. Okay. So and with the fact that this is equals to a root 3, then we can then solve for something, okay? So we have the first thing to solve, which is the p square plus the q minus 1 square plus the 1 square, and then we square root it is equals to, that's equals to root 3, right? That's from part B2, okay? However, if you have to see the big picture, it's you have two unknowns. Two unknowns, you can't solve it in one equation. You need two equations to solve for two unknowns. So what is the second equation? We haven't used the dot product too much. So maybe, and that's the dot product, right? That's the easiest thing we can do. So we may use this one. So because the fact that it's a u times the v as dot product is equal to 3, so we can then write it out as p and then q minus 1 and then 1 times, what is a v? The v, it's 3, 1, negative 1. 3, 1, negative 1, and that's equals to 3, okay? So how can we sort of like write it out? It's like this. That's like this. So which is like 3p plus q minus 1 equals to 3. So we attempt to solve for this one. It's minus 1, which is minus 2. Minus 2, this one is a plus 2, which is a 3, which is a 5. So 3p plus q equals to 5. Q equals to 5 minus 3p. All right. Okay, then we're going to go back and see this part a little bit, which is the original equation. We're going to go back and work with the p square, which is plus the q minus 1 whole square plus actually plus 1 equals to 3. We can remove the brackets correctly. Then we can have p square plus the q minus 1. Actually, it's equals to 2. So we replace the q with the 5 minus 3p. So p squared plus the 5 minus the 3p minus 1 square equals to 2. So p squared actually is plus 4 minus 3p squared equals to 2. So we break the bracket a little bit, expand a little bit, which is like p squared plus 16, and then minus 24p plus p squared, plus 9p squared equals to 2. We move things over a little bit, which is like 10p squared minus 24p, and then plus 14 equals to 0. Simplify, divide by 2, which is 5p squared, minus 12p plus 7 equals to 0. We factorize these two, which is a 5p and the p, and then we put a 7 there, and then minus 7 minus 1. Yep. Cross multiply, you're gonna have negative 7p, negative 5p. The sum of their cross multiplied product, which is negative 12p. Okay, so which confirms with our middle term. That means our answer, our factor should be read it like horizontally as 5p minus 7 times p minus 1 equals to 0. Therefore, your p will equals to 7 over 5, or p equals to 1. Okay? Correspondingly, the q is equals to 5 minus 3 times 7 over 5. Okay? Which is, what is that? Which is 5 minus 21 over 5. Which is 5 minus, this is 4, and 1 over 5. That's going to be 4 over 5. All right? So when the p is a 1, the q equals to 5 minus 3 times 1, which is equals to 2. Okay? So these are the two answers. When q equals to 4 over 5, p equals to 7 over 5. And when q equals to 2, p equals to 1. That is your answer. Okay? Yep. And then the last one. It's consider a new point D and then the W vector is a CD. So what is the condition? It says, okay, the dot product is a 0. Find the area of the triangle ACD. The area of the triangle ACD is 5 square units. Okay, 5 square units. So what does that mean? What does that mean? So that means you have to find, when the assuming P is equal to 1, find the possible values of the W. So ACD. Now ACD, it has another meaning, which is the dot product is a 0. That means it shall somehow look like this. Somehow look like this. Okay, that's the vector W, and that's the D. Okay, and we would like to know the area of this one. When the dot product is equal to 0, that means this one is a what? This one is a right angle. It's a right angle. Okay. So now you know there's one thing, which is the base times height divided by 2. That's the area, right? So now we can then write the steps. Let's try to analyze a little bit. See. So just now we actually copy a diagram down there so that we can see that easily. Okay. So copy and then paste. Okay. Let's take a look at here. So now we cancel these ones out first. Okay. So we have the base times the height divided by 2, which is the V times our W divided by 2, that's equals to the area. And it told us it's at 5, right? So that means the V times the W, and that's equals to a 10. Make sense? Okay. So now if that makes sense, then how can we figure the numbers out? It's first of all, we do not know what is the W, but we do know what is a V, right? What is a V? The V from the beginning, we calculate here. Okay, V is equals to root 11, right? The distance of V is equal to root 11. So this one is root 11 times the W, and then equals to a 10. So distance of W is equals to 10 divided by root 11. All right. So now we didn't define what is the W. So what is the W? The W, it's now we have the coordinates of the C, right? Where's the C? The C here is 3, 2, 1. Okay, it's 3, 2, 1, right? So the things that we can do is we can substitute it in first. Okay, we can substitute it in first. So let's say the vector. What is the vector there? The vector it's equals to, let's say we're assuming that's the W vector. The W vector it's let's say A, B, and C. Okay. So then now, if we want to find the A, B, and C vector, then the things that you can do is to sort of subtract, sort of to find the. 嚟個嚟個嚟個嚟個 So after this one, we have to find what is the vector W. Okay, so the W, let's just name it as W as, let's say, A, B, and C. Okay. And there's one more information that we haven't used, which is the fact that they are all perpendicular to the vectors, right? So we have to make use of this, okay? So since that, assuming P equals to 1, so we have another information. We have the, what is our U? The U is equals to the P when the P is a 1, so which is a 1, and then the Q is actually equals to the 2, right? So which is another 1. So U is 1, 1, 1, right? And then what is the V? The V is given by 3, 1, negative 1. 3, 1, negative 1, okay? So now you can see the dot product looks like different, which is what? W times the U is equals to A, B, C times the 1, 1, 1, and that's equals to 0, which means that dot product A plus B plus C equals to 0. How do we do dot product A times 1, B times 1, C times 1? You add it up together, okay? The next one is the VW times the V, which is equals to the A, B, C times the what? 3, 1, -1, and that's equal to 0. That means 3a, 3a, and then plus a b minus a c equals to 0. Okay? So now, what can we do? It's to try to substitute it in. Okay? Try to make use of it. So we do know that the b, let's say the b, okay? B is equals to -a minus c. Okay? And then the b is also equals to what? This b is also equals to c minus 3a. Okay, let's say in this case. Okay, why do we have to do it like this? So that we can make use of these two things. Okay, that means -a minus c equals to what? C minus 3a. So you move things over, plus c, and then plus 3a plus 3a. You're going to have 2a equals to 2c. So a is equals to c. Okay, and then by the fact that, okay, so that means now the w vector, you can then have what? Actually, this is a, and the middle is a b, right? What is the middle b? The b is equal to -a minus c, which is -a minus c. And you know that the a is also a c, so that means you can actually replace the bottom c as the a. So which is equals to what? Which is equals to a minus 2a times a, like this, okay? And we can make use of this one and then the distance to calculate what the a is, and therefore you can figure out what is the answer, okay? So you can have a squared plus the -2a squared plus another a squared, square root the whole thing, and that's equals to the distance, which is 10 over root 11, okay? So if you square both sides, you're going to have basically a squared plus 4a squared plus a squared equals to 100 over 11. So this one is how many? How many here? This is 1, this is 4, which is 5, 5 plus 1, which is 6. So 6a squared equals to 100 over 11. A squared is equals to, what is that? 100 over 11 divided by 6, which is 50 over 33. 50 over 33. Okay. So then now that means if we take the square root, so a is equals to the positive or negative of root 50 over 33. Okay. So then this one, if we factorize it a little bit, that's going to be 2 times plus or minus 2 times 25 over root 33. So which is plus or minus 5, sorry, yes, 5 root 2 over root 33. And then you have to conjugate it, which is times root 33 over root 33. So which is plus and minus the 5 root 66 over 33. Okay, that's the A. So that means your answer, therefore, W could be what? W could be plus 6, sorry, plus 5 root 66 over 33 minus 10 root 66 over 33 plus 5 root 66 over 33. That's the first answer. Or W equals to minus 5 root 66 over 33 plus 10 root 66 over 33 minus 5 root 66 over 33. That's the second answer. So these are the answers for the part C, okay? Yep. And of course, you can actually factorize each of them out, which is the 5 root 66 over 33 of the 1, -2, and then 1 like this, okay? Which is the plus or minus version of that. All right, so that's it. Thank you.